This is Math 6, Lesson 6-1, Multiplying with Fractions. Multiplying is simply repeated addition. So if we took 3/5 times 4, that means we would be repeatedly adding 3/5 4 times. So we'd have 3/5 plus 3/5 plus 3/5 plus 3/5, which would be 12/5, which if you change that improper fraction to a mixed number would be 2 2/5. When you multiply fractions by multiplying the numerator, that's the top number, straight across, and multiplying the denominator, that's the bottom number, straight across, and then reducing whenever possible. For mathematically, that means we would have 2/5 times 1/5 would be 2 times 1 over 5 times 2, which would give us 2/5. 2/10, which would reduce to 1/5. Algebraically, A over B times C over D equals A times C over B times D, where B and D cannot equal 0 because division by 0 is undefined. To multiply fractions, when multiplying a fraction by a whole number, first write the whole number as a fraction. Every whole number can be written as a fraction as long as the denominator is 1. So 3 can be written as a fraction. 3 can be written as a fraction 3 over 1. 7 can be written as a fraction as 7 over 1. If the numerators and denominators have common factors, you can simplify before you multiply. And I will show you how to do that a little later in this lesson. Let's multiply some fractions. Make sure whenever you multiply, you get your final answer in simplest form. Here we have 1/2 times 3/5. So, by the rule, we would take 1, multiply it by 3 on the top, and on the bottom 2 times 5. So the top becomes 3 and the bottom becomes 10. There is nothing that can simplify, so 3/10 is our final answer. Number 2, we would have 2 times 5 on the top and 3 times 6 on the bottom. 2 times 5 is 10. 3 times 6 is 18. 10/18 does reduce because I can divide that by 2. So I could simplify this by dividing both the numerator and denominator by 2. 10 divided by 2 is 5, and 18 divided by 2 is 6. Number 3, we have 3/8 times 5/7. So I can have 3/8, 3 times 5 on the top, and 8 times 7 on the bottom. 3 times 5 is 15. 8 times 7 is 56. Looking at this, I know that 3 and 5 divide into 15, but neither 3 nor 5 divides into 56, so I know that I'm in lowest terms. Now, let's look at some fractions multiplied by whole numbers. Remember, fractions multiplied by whole numbers, you need to change that whole number to a fraction. So I have 2/3, and I'm going to change my 6 to 6 over 1. The 6 becomes the numerator, and the denominator becomes a 1. Multiply straight across the top, that means 2 times 6. Straight across the bottom means 3 times 1. 2 times 6 is 12. 3 times 1 is 3. I know that 3 will divide into 12 4 times. So my final answer here is 4. Now that I don't have to put as 4 over 1 because it's my final answer and I'm simplifying it, and 4 over 1 and 4 mean exactly the same thing. Number 5. If I do 3/4 times 5, that's 3/4 times 5 over 1. So that would be 3 times 5 on the top, 4 times 1 on the bottom. 3 times 5 is 15. 4 times 1 is 4. 4 divides into 15 3 times, with 3 remaining, which means this becomes 3 3/4. Problem number 6, 5/7 times 8. So 5/7 times 8 over 1 means we'll have 5 times 8 on the top and 7 on the bottom. 5 times 8 is 40. 7 times 1 is 7. 7 goes into 40. Let's see, 7 times 5 is 35, so it would be 5. 40 minus 35 is 5, so 5 and 5/7. If you have to show the division on the bottom, you have to show the 40 divided by 7, by all means do that. So you can see that it's 5 and 5/7. Now there's this nifty little trick that you can do with multiplication that you could not do with addition and subtraction. Okay? If your numerators and denominators have common factors, you can simplify before you multiply. We call this cross-canceling, which is different than cross-multiplication. This is called cross-canceling because you're going across from the top to the bottom. So if I take a look at the problem 3/4 times 8/9, if I look at this, I can go, I know that 3 divides into 9. So 3 divides into itself 1 time, and 3 divides into 9 3 times. Notice how I just gently cross off my numbers. Don't obliterate them, because if you do this, and you make a mistake, you have no idea what that number was, which would be really, really bad. So you need to just cross off once and tell me how many times it divides in. 4 divides into itself 1 time, and 4 divides into 8 2 times. So now I'm just doing 1 times 2 over 1 times 3, which my answer is 2/3. Notice how I could have gotten the exact same answer by multiplying without cross-canceling, but I would have had to have reduced. If I have 3/4 times 8/9, and I just multiply straight across the top, 3 times 8, that's 24. Straight across the bottom, 4 times 9, that's 36. And then I'd have to look at this and go, gee, what goes into 24 and 36? Well, you might go, oh, well, 6. 6 goes into 24. 6 goes into 24 4 times. 6 goes into 36 6 times. Oh, wow, 2 goes into that. So I have to divide that by 2. So 2 goes into 4 twice, and 2 goes into 6 3 times. Notice how much more difficult it is because you have to simplify at the end, and you may not simplify all the way or correctly. So it's much simpler if you cross-cancel because it avoids the problem of having to simplify in the end. Let's look at problem number 8 here. 5/6 times 9/10. I'm looking at this going, is there anything that 5 can cancel into? Oh yeah, the 5 can cancel into the 10. So I might go, okay. 5 goes into itself 1 time, 5 goes into 10 twice. You might say, okay, what other things can we do? Well, 6 and 9, 6 goes into itself, but it doesn't go into 9. But 3 will go into both 6 and 9. So I can say, oh, 3 goes into 6 2 times, and 3 goes into 9 3 times. And you might not be able to read those yellows, so let me just go over those with red. This was 1, and 5 went into 10 twice. 3 went into 6 twice, and 3 went into 9 3 times. So now I have 1 times 3, which is 3, and 2 times 2, which is 4. So it reduces to 3/4. Cross-canceling is very nifty. It can speed up your process tremendously. Let's take a look at 3/4 times 12. First thing we have to do, 3/4 times 12 over 1. Now, the 1 and the 3, there's nothing that can cross-cancel there. You can cross-cancel diagonally as in an X, or you can cross-cancel up and down, straight up and down. And we haven't had any problems where you cross-cancel straight up and down, but it can be done. Because, for example, if I said 4 over 4, well, 4 goes into itself once, and 4 goes into itself once, this becomes 1. You can cross-cancel straight up and down. You don't see it very often, but it can be done. So here, I can say, okay, well, 4 goes into itself once, and 4 goes into 12 3 times. So my numerator would be 3 times 3, my denominator would be 1 times 1. So this answer is simply 3. Or excuse me, 9. Wow, I can't multiply. 3 times 3 is not 3. 3 times 3 is 9. Let's look at a word problem. There are 30 students in Sherry's homeroom. Of these students, 2/5 worked at the school fair. How many students in Sherry's homeroom worked at the school fair? So we know that 2/5 of all of the students worked at the school fair. So we need to find out, what is 2/5 of 30? That's what our question is asking us. What is 2/5 of 30? Now, in mathematics, this word of often means multiply. It's often an implication of multiplication. So what is 2/5 of 30 means I need to take 2/5 and multiply it by 30 over 1. I'm looking at this problem going, can I cross cancel anything? Oh, yes, I can. I'm looking and going, 5 goes into itself once, and 5 goes into 30 6 times. So 2 times 6 over 1 times 1 makes it 12. So how many students in Sherry's homeroom attended the school fair? 12 students attended the school fair. And there you have it. Multiplication of fractions is much easier than addition and subtraction because you do not need a common denominator, which makes it all much more fun to do.